our horizontal asymptote we found to be y equals 2/3. Our vertical asymptote, well, we know that that's constantly the thing that makes the denominator 0, so we want to figure out, well, what's going to make 3x plus 2 equal to 0? Now you can solve that however you want, but you're going to end up getting x equals negative 2/3. So that means that negative 2/3 will have an asymptote that runs through there. And that's x equals negative 2/3, the vertical line. X is always negative 2/3 along this line. That's how I like to remember that it's vertical. It's x that's always negative 2/3 along this point here. So this is y equals 2/3, x equals negative 2/3, and the question is, well, what happens? Do we get something that looks like this? Do we get something that looks like this? They all tend to have this similar shape, and the way we can figure that out is in a couple of different ways. Well, what happens when x becomes increasingly large? Well, these are both going to be positive for positive numbers of x. In other words, if I put in 2 for x and 2 for x, I'm going to get a ratio of positive numbers. So I know that the ratio will be positive for positive numbers. So that still doesn't tell me really which one of these two it can be, because technically the function can come up straight through the origin. But I can basically start looking at ordered pairs if I'd like to do that. So I see that the values are actually getting bigger. So if the values are actually getting bigger or closer to 2/3, so notice that we go from basically, oops, trying to go in the wrong way here. Notice that we go from 0.66556 to 0.6663, which is definitely a larger number. And so I think what we're going to see is something pretty similar to this guy here, and not this guy here. And in fact, we could take a look at that graph and see that that's exactly what we would find. If we just did just a zoom standard, since our function has an asymptote through negative 2/3 and positive 2/3, well, there you see it. It kind of looks like this, and it kind of looks like this one over here. So they're mirror images of one another over this point right here. Okay, so that's what our function would look like. What if we had different orders? So what if we had 2x plus 4 over x squared minus 3? All right, well, so now we notice that our order in the top is order 1, and we notice that our order in the bottom is order 2. So what's this telling us? Well, if the order on top is bigger than the order on the bottom, then this has the asymptote, the horizontal asymptote, of y equals 0. So that means that as x gets increasingly larger, my y values are going to tend towards 0. So here's my horizontal line, which actually runs right on top of the horizontal axis, and that means that basically my functions will get near, my function's output will get near this orange or pink line here, but will not cross it. So in this case, I know that the horizontal asymptote is y equals 0. Well, why is that? Again, if you'd make a similar argument, we could say that initially the numerator is going to be 4, the denominator is going to be negative 3. So that's great, but what happens as x begins to increase? Well, as x begins to get bigger, the numerator is increasing by a constant amount of 2. However, a quadratic, well, that's a 1x squared, that's a function whose rate of change is constantly getting larger and larger from what we know about quadratics. This is the term that tells us how quickly the rate of change changes. So the rate of change is actually growing, and if you were to plot this guy by itself, you'd get a function that looks like that. And if you were to plot this guy by itself, you would get a function that looks like this. So because the numerators are growing so much more slowly than the denominator, the ratio gets to be a tiny number over a very, very big number, which gets us closer to 0. Now, our vertical asymptote, we know, is going to be what makes the denominator equal to 0. Well, let's test that out. So we want to find out x squared minus 3, when does it equal 0? Well, that's an equation we have to solve. And you can solve it a couple of different ways. What I will do is I will just go ahead and solve it graphically and just do x squared minus 3, and then plot the horizontal line equal to 0 and see where these two functions intersect. So there's x squared minus 3, and we can't really see the y equals 0 being plotted, but it's somewhere back there. Now I can do second calculation.